Now we're going to discuss a version of the game of Snap. So this is played with a pack of cards. Normally you'd play with a full pack of 52 cards, but to make the picture simpler, we're going to only play with a pack of 16 cards. So just the aces, kings, queens and jacks. We've got 2 players, and each player has got a pack of 16 cards. And to make things simpler, we're going to assume that the left-hand player's pack, is not shuffled. They just get the aces in order, then the kings in order, the queens in order, the jacks in order. It doesn't really make too much difference to the analysis we're going to do, but it's simpler that way. But the right-hand player's pack is shuffled. Okay. So the way the game proceeds, we draw the top card off each pack, and we see whether the 2 cards have the same value. So in this case, we've already got a snap. The very first card we draw, both players get an ace, and so the game stops. So let's try again. We reshuffle. Again, this time we stop at the first stage, both players get an ace. Wasn't very interesting, we'll try once more. Okay, so now the first time we get the first player gets an ace. The first player will always get the ace of clubs, because remember the left-hand deck is not shuffled. So the left-hand player will always get the ace of clubs, then the ace of hearts, then the ace of diamonds, ace of spades, and so on. And we place a rook to indicate the combination of cards that we've got. The first player gets the ace of clubs, the second player gets the jack of spades. So we put a rook in this position here, ace of clubs, jack of spades. And it's always this is in the first row because the left-hand player has got the ace of clubs, and that's always going to be the case because the left-hand pack's not shuffled. So we're always going to get a rook in the first row at this stage. We draw another card. So again, the left-hand player is always going to get the ace of hearts next. So we're always going to have a rook on the second row. And now the second player has drawn the ace of clubs. So we've got our rook is here, ace of hearts, ace of clubs position. That's in this black square here. It's in the black square because this black square is where we've got 2 aces. This black square is where we've got 2 kings. This black square is where we've got 2 queens. This black square is where we've got 2 jacks. So we've got 2 aces, 2 cards of the same value. So we're in one of the black squares. And the rules say that the game stops at this point. That's all we're going to care about, whether the game stops or not. So let's try again. Okay, so this time we draw, as always, the ace of clubs for the first player, the queen of clubs second, different values. So we're not the same value, so we're not in one of the black squares, and we can carry on. Here we get ace and queen, again, different values, so we're not in a black square. Ace and jack, different values, so we're not in a black square. And as always, remember the left-hand player is always playing just down this row here, so we get a rook in the third row. Now here, as always, the ace of spades for the first player, king of spades for the second player. Again, that's not in a black square, so we can carry on, and we carry on. But eventually at stage 6, we've got 2 kings, so the corresponding rook is in king hearts, king diamonds position in the black square, and the game stops. And so let's play another game. Another game, and another game. So here we stop at the third stage. Here we stop at the second stage, third stage. Here we get as far as the 5th stage. Here we get somewhat further, down to the 10th stage we stop. Okay. So you can see it seems like it's not very likely that we're actually going to get to the end of the game, having played out both packs. It's quite rare to get down even as far as here as stage 10, and so far we've never managed to get all the way down to the bottom. And in fact, it turns out that the probability of getting all the way to the bottom, of playing out both packs without seeing a snap, is only about 1%. So we'd have to play 100 games before we'd expect to do that even once. So in order to prove that, to calculate the various probabilities, we need to understand the number of legitimate rook placements for this full board. Okay, so the number, if we had the whole board white, then the number of possible rook placements would be 16 factorial, right? We've seen already, if you've got an n by n board, all squares white, there's n factorial ways to place the full set of rooks. Then we want to work out how many ways there are of placing 16 rooks on this board, not challenging each other, but with none of the rooks on any of the black squares. Okay, so that's one of our standard kind of rook counting problems. And then we divide that by 16 factorial. That will be the probability of finishing a game of Snap. And now it's if we wanted to place rooks on the black squares instead of the white squares, then it's not very hard to count a number of ways of doing that. Okay, so you've got you've got 4 separate boards, each of size 4 by 4. If you wanted to place 16 rooks on the black part, then you would just get 4 factorial to the power 4th ways of doing that. If you want to place less than 16 rooks, but just using the black squares, well, again, it's not too hard to work that out. We'll discuss the technique for that later. And then there's a kind of version of the inclusion-exclusion principle that allows us to take our analysis for the black squares and work out the corresponding numbers for the white squares. And as we said, once you've worked out the number of ways of placing 16 rooks on the white squares, you can divide by 16 factorial, and that will give us the probability of finishing the game.